that button right there should be the button that I hit it up on the screen. Oh my goodness. Hello, everyone. Sorry, everything's changed yet again in the studio, but for the better, I promise you.
For the better, we hope.
James has just walked out and he's just taken me through the express lesson of how to use this beautiful new Stream Deck configuration. And I literally only had to push up, up, down, down, left, right, BA, start to get the stream to start. No, I only had to push 2 buttons. So
it has some
like
cool stuff
working.
too. It should show the number of viewers in one of the restream buttons.
So it does. It says there's 36 people
magic?
on red, which I'm assuming is YouTube, and purple I'm assuming means Twitch, and it shows nothing right now. So if I go to Twitch, I'm going to have a look at that.
Well, I see 14 live on Twitch.
Well, then I'll just blame James and say the Stream Deck's broken.
Yeah, we do see Twitch icons. I see.
We are live. I can see it on Twitch. All right. Well, this is the smoothest start I think we've ever had.
You're welcome.
For the current results. I apologize for the. We are back on the stationary mics, and so I personally very much dislike these mics because I like to do this to the top, and then you can't hear me because I'm over there. So I will try to be disciplined. John, tell me if I drift.
Okay.
During the show, and I will move back. All right.
Yeah.
We'll just cough gently.
Or cough. You kick me under the table. Okay. We have a guest this week.
Yes. That's exciting.
Mm-hmm.
This is my good friend Brady Gaster.
Hi. It's my first stand-up. It's good stuff.
Is this the first time we've had you on the show?
That's just terrible.
That's criminal. It's criminal, not just terrible. Now, Brady now works on my team.
Mm-hmm.
How long has it been now? How long have you been on my team?
October.
Mm-hmm. So 6 months. This is like a 6-month thing coming up.
Mm-hmm.
Like literally this month. It's
good.
probably already happened already.
Yeah.
We should have done something.
That was October 18th.
Oh, it's happened.
Yeah.
It's over.
Yeah.
Okay.
That's good.
Well, there you go. And Brady looks after SignalR.
Mm-hmm.
Very dear, close to my heart, obviously, and I've handed the baton on. Usually now when people ask me SignalR questions, I go, that's great. Let me introduce you to Brady. And then I get Brady to answer them for me. And I also have Brady looking after a lot of our Azure integration. And so he often is chasing down Azure things for us and helping customers and getting docs correct and designing new experiences to make .NET and ASP Net Core work great on Azure. So
or just hacking on things to make sure
just hacking on things
work.
to make them, does it still work? Does it work well? Could we make it better? All that type of thing. And he's also helps Glenn with some of our services and microservices type stuff as well. So Brady's doing great stuff. But before we get to Brady, John, you know what I'm going to say.
You're going to ask if I love the community.
Know what? I expect you one day to, when I switch to you, you just have a big love heart on that lovely dome of yours. And the word community right above your eyebrows.
That's right. Well,
it'd be better.
I was actually going
to
look
top,
and see.
You just do this.
What if we got like a .NET purple heart temporary tattoo?
Oh, you can put it on the back of your head and you can just turn around and go, oh, definitely love the community.
I was looking to see. I'm pretty sure we're streaming live on Facebook, although I still don't know how to do it. But
okay,
maybe you can. I don't know. So I'm sure there's somebody out there. I'm going to share my screen.
Okay, and I'm going to hit this button and make you full screen.
Hooray! All right. Well, I'm going to start with Scott Hanselman. Scott's been doing some kind of like short level setting kind of posts lately, just kind of explaining what some terms are and stuff. So Blazor, and here he focuses on the difference between Blazor and Razor components. So just kind of a backup, and here's some things, points out what's in the docs and explains, of course, the Blazor client side hosting of Razor components, and then Razor components, same thing, but SignalR, neat term for today, SignalR communicating back to the server. So the magic processing stuff happening on the server, the .NET code running on the server, the communication, going over SignalR to the client. But the same programming model with Razor components on the client.
Yeah. So like we've been discussing this, and we might reserve the right to tweak this, how we talk about this a little bit. So what we're finding, right, is as Blazor as an experiment, we start extracting goodness from that experiment and trying to put stuff in the product, Razor components in .NET Core 3. We want to make sure that we choose the right terms to represent the right app models and parts of the stack and and are you building a Razor Components app, or is it a Blazor app, or is it only a Blazor app when it's on WebAssembly, or all that type of thing.
Yeah.
And so my hope is that by build this year, we will have gone through all the internal throws with marketing and all that type of stuff to land on how we will refer to all these things moving forward now that we're like actually shipping bits in .NET Core 3. But yeah, this was Scott's first attempt to try and just say, hey, yeah, there's Blazor, and there's this that's built on this thing called Razor Components, and we're going to ship Razor Components in .NET Core 3, but we still have Blazor, and yeah.
Yeah. It's funny. I'd recently done some presentations on it, and I had my own kind of like ways of pointing to this. A lot of the time when Scott, I'll be like, oh yeah, I should dust off my blog and blog about it, and then Scott does a nice, clean, straightforward post. I'm like, yeah, that's better than I would have done. So There you go. But this is nice. So here is a from on.net. They've been doing some cool Asp Net content lately. So this is a nice one. And so here, this is from, it's not, gosh, where's the names? They moved on me. There it is. Hassan and Jeremy Lickness are talking about Odata with Asp Net Core. So they're talking about, some interesting things, like starting with the basics, but then digging in a little deeper, like things like defining, ordering, and including related entities. I haven't used Odata a bunch lately. Well, I hadn't for a while until recently. I've been using Microsoft Graph more, and that's all Odata. So that's kind of reminding me of what Odata is. So there you go.
Cool.
And nice to see Cecil and team. They've been doing a lot of stuff with Asp Net Core lately on the on.net show. So good stuff. All right, Cesar talking about ML.net. So what's cool about this is he's kind of starts with the basics, and I've looked at some kind of simple stuff with ML.net and Asp Net Core, but he digs in pretty deep with how to scale it. So as you go through, he's looking at some kind of when you've got multiple clients connecting and you've got a lot going on, how you actually scale up that ML on the back end. So he actually digs into two different options here. And so he does point out, regular Asp Net Core apps, you're not normally going to run into this. But as you scale, this is an issue. So here he looks at option 1, which is registering a singleton of the ML model. So this is kind of the kind of simpler case here. Mm-hmm. So then he goes in and does a more complex look at sharing the prediction engine. The prediction engine is not thread safe. And so he goes through and explains, and this is more in depth. So this is if you are really, not just messing around, you are seriously scaling this up. This is, I think, what you would dig into doing. So then he goes through and shows how to use the object pool in order to do that.
Cool.
So yeah, a lot of good code, of course referenced at the end. And Cesar always does these great diagrams too, so I got to give him props for that.
Yeah, so he's been working with Glenn on my team and Ryan, the architects on Asp Net Core, and my understanding is they're going to take this post and rev a bunch of the code, and the intent is that we'll actually ship this as a proper integration package. And so rather than you having to go and write very complex pooling code, because the example here still has some scenarios where it won't behave particularly well because of the nature of the object pool class that he's using. For example, if you want to grow the pool, there isn't a great way to grow it asynchronously. And I'm not sure if it shrinks the right way either. And because the prediction engine objects that you're pulling are actually quite expensive to create, which is one reason why you want to share them if you can, but because they're not thread safe, that makes it difficult, obviously. So you need some type of pooling mechanism. So Glenn showed me a prototype of actually something yesterday where rather than having to do all this stuff, you basically end up with just a nice extension method on services in your Asp Net Core app. So you can just say like services.addML model of T, right? And you add your T POCO. And then because ML.net is all designed around POCOs, so you have a POCO input to your ML model and then a POCO output, that works really well with Asp Net Core, controllers. So you just have your POCO, it binds from the body in an API controller. Asp Net Core binds it for you. You run it through the prediction engine, and then which was retrieved using a new type, which is a thingy pool of T, where T is your model. and then you return the response, and you get this really nice, familiar sort of Asp Net Core Web API /MVC experience, but it can be backed by the set of types that does all this good for you as well. So good things coming here.
I'm having deja vu. We had that conversation right before I left to come over here.
There you go.
He came over and was all excited about it.
Awesome.
I got it working in one line of code.
There you go.
You know, I love that when we dig into, we build something out and we go, this is too hard, and let's figure out how to make it easier. So that's a cool example here. Cool. Okay, here, David Pine. This is an interesting idea. He uses Slack at work. He wanted to have some other slash commands. So to be able to slash joke, and it tells a Chuck Norris joke, or also to look up weather, and then probably a more useful one to shorten a URL. So take a long URL and make a short URL. So what he did for this is spun up a web API backend. And so he's got Asp Net Core Web API, and then he's calling back into that from Slack. So here he just shows kind of how he wires that up, calls it from HTTP client, and then the end is you're able to go /joke and actually get a joke in the chat. So increasing work productivity using Asp Net Core.
Cool.
That's good stuff.
Yeah. So Ryan Nowak, this is actually from NDC London, and I know we called out content from NDC London, but I don't think we gave this one kind of the proper credit or whatever. Really called this one out individually. This I saw someone tweet again about this recently, and this really is a good presentation. Where
wow, I haven't watched this. I totally didn't watch this. I'm sorry, Ryan.
Lessons learned building Asp Net Core.
Brady, we're just going to watch this now. We're just like, we're just going to watch. They can turn the show into just watching this because this sounds great.
So see where it says 1,000 views, that should be like 10 million views.
Wow. Okay.
So yeah, really good stuff here. And of course, as you can guess, like deep technical content in there. So.
Is it easy to, if I just literally search for, what was it? Learnings? What is it?
Lessons
learned.
Called Lessons Learned Building Asp Net Core MVC.
Building ASP.NET Core MVC. Oh yeah, first result. Awesome. Thank you.
There you go. Stuff from a very spicy boy. All right. So Chris Sainty, so Razor Components does have forms validation built in. It has the it has data annotations based validation. He wanted to use Fluent validation. Fluent validation, of course, allows you to write validation using this kind of Fluent syntax. You may already have some Fluent validation rules, or you just may prefer that. So he goes through and shows how he switched out the validation to use Fluent validation. So he did that first by building a forms validator component, and then he hooked that in here by extending the edit context. So, it's not a huge amount of work. You do have to go through and hook up events and stuff. If you are, it's interesting to see, both in terms of, hey, you can swap this out. That always makes me happy to know that it's possible. And then also, if you do want the code, he's got it for you. So here's his repo there. So, good stuff.
Good stuff.
All right, so Shahed, continuing this A through Z series. He's actually, since we weren't on last week, there's 2 that have come out. I'm going to highlight one here. So this is K for Key Vault, and then there's also another one this week for logging. And the logging one, he goes into Serilog and all the kind of stuff on logging in depth. Some stuff for Key Vault here is starting with the basics, but then digging into some stuff like here, managed service identity. So this is something where, like say if you're developing locally, how are you using Key Vault and how are you handling that? So you've got options. You could use like app settings and, kind of override. You can also use the things like you can set in Visual Studio. You can configure who is my identity when I run the application. So some good stuff here. I always like the depth here. He's really going in deep on these. If I'm going A through Z and I get to K, I think I might be at a tweet length here, but he's really continuing to keep the quality level high.
Awesome.
Yeah. All right, Scott Allen. Here he's been writing .NET Core opinions, and these are opinions. So I saw he tweeted it, and someone else was like, "I hate that opinion," which I think is okay. That's all right, right?
That's why they're opinions.
Yeah. So he is saying that, as you're going through and doing configure services, a lot of time the lambdas end up getting pretty long. So like it's very easy to get into a configure services that's a couple hundred lines long, and you're scrolling, and then people are commenting things out, and it can be a little much. So some people prefer that, have all the code right in front of you, nothing's hidden, it's all right there. What K-Scott likes doing is actually having extension methods. And so here, for instance, instead of saying add MVC and having all the Lambda stuff here he's just calling add custom MVC. Oh, that was neat. Look, it's expanding. Why is it doing that? Now, I don't know if I can ever get to
You broke his blog.
I appear to have broken his blog. Don't double click in the code blocks.
Whoops.
What on earth? That was amazing. So here he's actually just built out an extension method, add custom MVC. And now, because I'm about to navigate away from this page, I'm going to double click again just to see that. That's crazy. Good stuff.
That's funny.
It's an Easter egg. So it does allow me to copy it. But good. The one last final link I want to point out here is our show suggestion. So we set this up in case there's a topic or a guest you'd like to see. We have these Tuesdays as Asp Net Community Stand-Up. The Thursdays we dig into other things like language runtime, cloud tooling, and mobile. So there, you'll see at the end of the stream there'll be a thing in the footer of the ending slate, and then it's at aka.ms.net stand-up suggestion. So that'll take you to this form. So already some good responses on this, and then we can dig into these and see exactly what you would like to see in the future.
Awesome. Look at that.
Good stuff. And that is it for me. And I want to see some SignalR.
All right. Well, Brady.
Yep.
What's been going on in SignalR since I haven't really been looking at it in a while?
Yeah, well, you've always been looking at it.
Well,
it's like in the room with you and
I
stuff.
approve the high level stuff, and I ask what's the direction. They go X, Y, Z. I go, sounds great.
Yeah, he asks what's the direction. I just go, we're doing cool things.
That's right.
That's
as long as it's great and cool, then I approve it. That's basically it.
Well, we have a lot of cool things coming up in our 3.0 timeline. Actually, we had a meeting yesterday where we actually went through the various things that we have in our milestones. As you know, we have a lot of preview releases coming up.
We do.
So we've basically stuffed a lot of features into those preview releases. So the big things that we have coming up for our 3.0, GA timeframe are going to be a big one for everybody in gaming and IoT and anything embedded, C++ client. Woo! So we're actually going to have a native C++ client, which is very exciting.
Okay.
And then we can do all kinds of fun things with that. We have a couple of internal customers that are already looking at using that.
What target devices and environments will that run in? Like all OSs?
Pretty much all OSs.
All architectures?
Since it's going to be C++, we feel like that would be, one question that we've had is from the PlayFab folks, the recent gaming partnership.
Right.
They had native stuff they needed to do.
Okay.
So we started to work with them. So gamers will be able to, or game devs will be able to use the C++ client to do things in real time. Like I said, the one that we talked about, we've debated this one. We think that we'll have some IoT plays as well, some C++ stuff. I know I was just listening to a podcast this morning with Sue. Sue's on the MX chip. That's not C++, that's native C. It's actually the Azure board, but I can imagine that some of the higher order boards could probably party on that eventually as well. One thing we've talked about, Mr. Fowler and I have talked about, is what we want to do beyond the C++ client is get to a native iOS client.
Right.
So we've seen a lot of folks start with C++, and there's this thing, I guess it's Objective-C++.
Objective-C?
Yeah, but there's this thing called Objective-C++.
What's that?
Apparently it's a super highfalutin version of Objective-C. Yeah, we don't really know a lot about it. We've talked about it, but apparently there are ways that you can port the C++ client into other languages or into things like Objective-C. Another one we've talked about is Rust. We've talked about doing a Rust client.
I like it. How complicated are the clients? Like, how hard is it to write?
Very hard. Very difficult. We have our 3.0 timeframe. Primarily, we've had one dev whose primary responsibility has been writing that client.
Okay.
So imagine a 6-month dev timeline plus Christmas break.
And that's because we want to do it well. Like, to be clear, like if I recall, I think it was Brandon who originally wrote that. Mm-hmm. You can get a prototype up and going and get basic things working usually within a few days. Right. Because the protocol is spec'd. But building a good networking client that supports the protocol, handles all the crazy conditions that can occur because it's networking, is reliable, is performant, doesn't leak memory, takes
Quite
a
some
lot
time.
longer. And then on top of that, we added features in 3.0, so the protocol got extended.
Exactly.
Yeah.
So if you think about that, like Damien mentioned, the protocol, I actually just pulled this up. We actually have a SignalR Hub protocol, which we did for, I guess that came out around the SignalR Core timeframe, the ASP.NET Core timeframe.
Yes.
We sort of revisited everything and said, well, we want to take this more seriously. So we buckled down, wrote the protocol, and now all the clients adhere to that protocol.
Okay.
As does the service, which we'll speak to later on in this conversation. As Damien alluded to, building a client is very expensive. One of the parallels that I have, I used to work on the Azure SDK team, and we had 9 languages and 80 services that all wanted SDKs. So that gets a little expensive. So if you think about, today, app service releases a new feature, we don't just go fix that in the API. We also fix that in end clients for that SDK. Well, the same thing would be true for a SignalR client. Today we have TypeScript, JavaScript, Java. We will have C++, C#, obviously. And then, we know that there are some community ones out there that have been built as well. One that we've talked about a little bit is, I think it's called SwiftR. It is actually a native iOS client written in Swift. But what you'll see later on today is that you can actually use SignalR's .NET client from within a Xamarin app. So if you're using Xamarin, you can actually target any of these platforms and party on them. Okay. So we'll go into that later on. But one of my favorite features that we're going to have coming out around the SignalR 3.0 or the ASP.NET Core 3.0 timeframe is going to be the concept of streaming. So I've actually just pulled up the doc page here.
And I got a little distracted by the
it's okay.
by the stream deck.
That's fine. It's very distracting. So what I've just pulled up here is our URL for streaming in the ASP.NET Core SignalR client. And one thing I do want to point out to everybody is we have a handy shortened URL. So if you want to get to our SignalR docs very easily, it's akams/SignalR/docs. And we've also got one if you want to send us an issue. We can actually do issues here as well. But I do want to show you that this is our streaming client, our streaming server to client implementation, which came out, I guess, 2.2. Is that right? .NET Core 2.2 is when we released.
Sure, that sounds right.
Sounds good to me.
Yeah.
That's around the time I joined, so it doesn't matter.
That sounds about right.
Yeah. But what I'm really looking forward to, and I've shown this demo a little bit at VS Live and also on this show with Cecil. Thank you so much for having me on the show. If you want to see this demo in a little bit more exhaustion, you can look at it on YouTube. But what we have over here is a new feature that we're going to have coming out in the 3.0 timeframe, which is going to be client to server streaming. So what I'll do here is, if you look at the URL, it's streamer without the E, because that's the SignalR naming convention. Streamer.azurewebsites.net. So I'll go here and I'll just type the show, and I'll hit start streaming, and it should ask me if I want to use my camera, and I do. And now we're actually streaming, see here? And if I were to scroll down, you'll see that we actually have a photo of me or a video of me right here. And what we're doing with this video is...
Oh, it is live, look.
It is live.
Okay.
That's cool.
That is crazy.
What we're doing is we're actually taking this video, and for each frame, we are generating ASCII code, and then we're sending, this is important, we're sending that ASCII back to the server, and then it's going back out to all the clients. So when you see it rendering on screen,
wait a second,
it's already gone to
John.
Yes.
We need to call him out. This is a live site, right?
It's a live site.
Yeah.
Don't touch anything. You're not allowed to touch anything. Take your hand off the keyboard. John, I need you to open this tab.
All right.
Please.
Stream,
and then I will put you, and then you need to share it to the call so I can show everyone. In fact, we'll see it in the bottom right-hand corner. So you need to change to share your desktop right now once you've got it up. And we can observe the raw power of ASCII SignalR. Well, actually, we can see the lag too. So
the lag.
I'm assuming it's going to be somewhat. It's the Teams lag that will be notified, that we'll be seeing more than anything.
Yeah.
All right. So what does he do? What does
he do?
Watch
available
streams.
Watch the show. Watch the show stream. There you go. So now when you move, look at that.
This is So
look
maybe
at that.
So we could stream now on YouTube, Twitch, and StreamR.
And then if I wanted to be really I could join the stream. I could join the call as well. And no, unfortunately, you can only share one desktop at a time. That's pretty cool.
Isn't that cool? Isn't that great?
I could share the community links over there.
That's true.
And then Scott would be like, zoom in, no, zoom out.
So
Yeah, all right.
So I'll kill that. And you mentioned a new friend of mine as of last week at our little internal conference here. David Pine. David Pine has a different version of that demo that he did with Angular. So if you're interested in the Angular version of this, David Pine has a demo of that, which I believe he's going to debut at NDC Minnesota. Is that right?
Okay. Yeah, in
so
May.
he's going to be at NDC.
All right.
He's going to show this off. It looks really, really good. It's going to be fun.
Cool.
So it's going to be good. So that's our client to server streaming, which is something that I'm definitely looking forward to in the 3.0 timeframe. In terms of its preview release, as you can see, it's already out. We just partied on it. So that's actually out. I think that was preview 2 or 3 that it actually came out in. So you could try out the preview now, and you could, give that a shot.
Please do.
On it. Please do. And if you wonder, if you run into anything weird, we have a shortened URL. So, aka /SignalR/issues. Send us an issue and let us know you have a problem.
Previews only get better when people use them and give us feedback. That's
Correct.
the reality.
Correct.
So thank you if you are a preview user, and if not, I encourage you to please find some time to try the previews.
And if I could get done with these demos, eventually I'm going to write a blog post on how you could use Azure DevOps to do a preview, how you can deploy a preview, ASP.NET Core 3 preview app to app service, without having to get into the weeds and understand all the goodness.
Okay. Yeah. The easiest thing, if I recall, is just self-contained. That's what I do now. Self-contained.
Self-contained. It's 3 steps.
Thing.
3 steps. Jeff and Richard and I did a quick demo of that last Friday on the Dev Intersection show.
Okay.
So if you want to see that, you can check it out.
Cool. So we've got new clients, C++ client coming in 3.0, discussing further clients.
Discussing
so no
further
commitment
clients.
to those for 3.0 or
Correct.
anything, but
Correct.
beyond 3.0.
Correct.
Okay, so whether it's Swift or Rust or whatever
Objective-C.
else it might be, C, or just like raw,
C-ish.
an assembly client,
assembly client,
Go client, who knows?
Yeah.
And we've got client server streaming.
We got client server streaming, and then one that we've been asked for quite a bit, which I'd love to hear the history version of this. Is in ASP.NET SignalR. We had this
SQL?
awesome thing.
SQL? Oh, come on. Tell me you want the SQL
wonderful.
provider.
SQL CLR.
I can't do that.
I wrote the SQL provider.
We know.
I'm not writing it again.
We know. You threw me off.
Sorry.
Talk about reconnection.
Ah, yes, that's coming, right? We're doing
that's
that.
coming. That's coming. Okay. So our good friend Stefan Halter is re-implementing.
Stefan's doing that.
Stefan's doing that. So he's re-implementing.
But who's working on Kestrel then?
He's working on that too.
How can he do both things?
He's a tall guy.
So is it going to be reconnect as it was in non-core SignalR where it does message? Okay, it's just.
We'll never do that again.
Thank you. Thank goodness. Okay, good. So, but at least gets you out of the problem of, it went down because of a tiny network blip,
right.
And now I have to write a bunch of code to handle that. It'll just transparently do the retries and reconnect. And then what would I do in my app to know what I missed? Or it's up to you. It's an app concern. If you care about messages that were
I can
missed,
tell this is a hot button for you.
It's up to you in the app. No, I've been the
I was writing a client.
I know nothing
Jabber.
about this library.
He knows nothing about it.
Yeah.
Actually, he knows quite a bit about it. Which is, it's actually kind of funny. The last time we had a show together was when I was interviewing you and David.
I think it was. It was like 4 or 5 years ago.
7 years ago. 7 years ago.
Wow, okay.
Yeah. So what Damien is alluding to is that under original SignalR, we'll call it OG SignalR.
Yeah.
Under SignalR OG, we used to basically replay your messages for you, which is a wonderful favor that has all kinds of pain wrought with it.
It works great until it doesn't.
Right. Yeah. And then it really, really doesn't. And then things get clogged. Yeah. So we're not going to do that.
Okay.
I'm sorry, Mosteric, that you missed that, but we just can't do it again. It was painful. We're not going to do replay, but we are going to do reconnection. And one thing that Mr. Halter and I've talked about are things like do you want to do exponential back off? Do you want to do you want to try 9 times with 3 seconds in between each time? So we're going to give you a couple of options there to basically dial in the reconnection logic.
Okay.
But there's an important question you're not asking me here. Are we going to reconnect automatically for you? No. And the reason we're not is we turned it off. So we wouldn't just automatically turn it back on. That would be rude. So it's going to be an opt-in.
Okay, that's fair enough.
So yeah. So if you want to enable global reconnections, you would opt in.
Sorry, while I was tuned out there, I heard some words that seem to imply that we will have options that allow for staggering reconnection, so that you don't have 1 million or 400 clients suddenly reconnect to your server if there was a server-based network.
Right, I've asked for that. I've asked for like an exponential back-off type of approach.
Okay, because that is a common problem we had with the old logic, was that you'd have 1,000 WebSocket connections on your server, you have an automatic reconnect logic in place with no delay. And so if the server blip, if the network blip wasn't a client-based blip, but rather something on the server side, so you dropped all 1,000 connections at the same time, they'd all turn up instantly again in the normal case, and that could cause problems if your server doesn't handle 1,000 people turning up on the door and knocking on it.
And even with you mentioned exponential backoff, but that doesn't completely solve that, because you still have all of those clients at the same time.
Right. That's correct. So technically, exponential backoff is a slightly different thing, which is if you try to connect and it says no, then you get exponential backoff in terms of how long you'll wait. There's also the concept of randomization, which is, should you have a random window of some sort rather than having everyone in between each reconnect or even for the initial one. And
because otherwise they'll flood.
Yeah, and so otherwise you get floods. And so we've talked to teams at Microsoft at large scale who do networking, and it's very common that when you end up doing this type of thing, these are common features you end up having. And this is why doing this type of stuff is not straightforward. You just build a standard TCP thing, like nothing does this for you. You have to do it yourself. Right. And the goal of SignalR is that if we're going to do these type of things, we want it to kind of work for most cases most of the time, and you don't have to dig down and go, oh yeah, so my server was running great, there was a blip, and while it was handling 800 perfectly, when they all turned up at once, only 200 of them connect, and then they all kind of had to wait. Right. Yeah, it's just hard.
So it's like a staggered. We have a staggered reconnection problem. Yeah.
Yes. Exactly. Okay. So, okay. Cool.
Now, question. You mentioned that that replay is really hard. Let's say I just had that as a business requirement. I mean, I could like keep a record of recent ones and keep a ledger, on the server and the client, and say like which ones I've gotten. Is that?
Oh, it's so simple, John. Why don't we just do that?
No. I'm wondering like what I would do. I believe that everything about SignalR is hard. You don't have to convince me.
So no, if what we had kind of determined after doing this 7 years ago was that the reality is that it's really an app concern. There are many apps where you do not care about missed messages. Like when we built Shooter, the game, where we were sending 20 frames of messages to each client per second and 5 frames up, you don't care if you miss a message in there, because we're going to redraw it in the next, 28 milliseconds anyway, right? So it all depends on the application. So if you care about missed messages, it's your responsibility as the application developer to think about your messaging strategy and implementation and go, well, okay, if I'm building a chat app, even Jabber did this, right? The rest in peace. Jabber used SignalR for the real-time aspect, but it also persisted all chats to a database. And so if you joined again later, you would go, on the client side, there was state stored in IndexedDB.
Oh, counting.
It would go, well, I know where I am because like I have a timestamp or whatever, like a message ID, right? And it would literally make a database query. Like the client would connect, there'd be a JavaScript thing it would call, it was a web API, it would say, get me all the get me the last 30 chat messages for the room, right? And then we'd give you those, and then it would make the SignalR connection so you get them as they come in. When you reconnected, rather than just relying on the message replay, because we use the SignalR connection not just to get the messages, like all the typing status, the presence, like everything went over that SignalR connection. You don't need all that stuff. Right. You just want, give me the current state at the point I'm reconnected. Does that make sense?
That makes sense.
And so it's up to you to determine what you need to know in the state that you reconnected. So you'll get an event. When we do reconnect, you'll be able to tell client side the connection's gone offline, and we are reconnecting. And we will fire another event when it is reconnected, or if we have to back off. And so you can write app logic that says, oh, I'm reconnected now. Let me go back to whatever I stored when I was told I was disconnected, and use that to make an API call or a SignalR RPC call, whatever you want, to say, get me everything I missed. And then your app gets to decide what's important there.
Right.
That's what we mean when we say it's an app concern.
Yeah, it's definitely an app concern. And the point that Damien makes is actually the point that it's always painful to have to say it, especially like I've talked about how SignalR is my favorite thing for 7 years, and it's definitely a truism. But whenever I talk to people and they're like, well, I can't figure out how not to use it, I'm like, that's a problem.
Yeah.
Like, that's a problem. And I'm like, let me explain it to you. Like, let's say you want to build it to replace all of your REST APIs and a shopping cart experience. That's great. That's a wonderful idea until you get that one order with like $100,000 worth of stuff in it.
Right.
Like, if your luck is anything like mine, that's the one message you're going to drop. And you don't want to drop that message. So, and then the next question is, well, how do we solve this problem? Well, you don't use SignalR for that.
Right.
You would use something like Event Grid or Service Bus or RabbitMQ or MSMQ or something along those lines. We just talked about this last week. I feel like I'm saying this every day. You might have your enterprise, I call it this, your enterprise pub sub layer, your durable messaging layer. That's right. Pick your poison down here. And whenever messages go from this queue to this queue to this queue, if you want to notify some sort of a UI, well, you'd have a SignalR on top of that as almost like your UI messaging layer.
Right.
So hyper simplify it.
Yep. I've heard a couple of analogies over the years in SignalR about how to explain this difference. Like one is treat SignalR like you would a raw TCP connection with nicer RPC semantics on top. But TCP isn't durable in the sense that if it goes down, you don't get messages that you missed while it was down. And it doesn't reconnect for you. It'll do error correction while the connection is up within tolerances, and both sides will resend. We don't even do that in SignalR. But once it goes down, it's down. Like you reconnect it, and it's just a new connection with a new ID, right? And then we have so you have layers on top of that. You have protocols on top of that, messaging protocols and messaging standards. As Brady said, you have reliable messaging standards, and there's literally dozens and dozens, probably hundreds of them. And then I've heard other analogies, like I was with a team that was building a whiteboard app once, and they wanted the strokes to be durable, but they also wanted them to be real time. And so the problem with the durable bus systems was that often they were slower, because guess what? Durability means you've written it to 3 different places, and if you're on the other side of the planet, all that type of stuff. And so they had this concept of wet ink and dry ink. And so the wet ink would appear instantaneously because it went over the SignalR connection. Cool. But the dry ink would, as the ink dried, you could literally see in the app change. Because what would happen is you would see the real-time pen location, and you would see the thing draw. And then once that stroke had gone through processing, curve smoothing, like they had some algorithm for turning it into vector, and that got written into their durable messaging system and then put into a database effectively. Wow. That would then, the app would pick that up a couple seconds later, and you would see the stroke change from the very real-time stroke to the more durable, this is the elliptical graph thing that I don't understand vector graphics, but that's what they did. And so you would literally see it in the app. You would draw a thing, and then as your eyes moved to the next thing, if you looked back at what the person had just drawn, you'd kind of see it crisp.
Oh, wow.
It would go, and it would lock in, right? Because, and if you've ever, there's some I've seen this in a bunch of whiteboarding apps where they do that, because to get good real-time performance, you want to kind of do things fast and loose, and the eye's looking at it, and then once it stops, you want it to smooth and all the rest of it. So that's cool. That's how they did it: wet ink, dry ink. And if the wet ink went down, you just wouldn't see stuff in as real time. It would take 3 or 4 seconds before you would see what the person was doing, but it still worked.
That's cool. That's cool. We had a question earlier. Somebody said, "I want durable SignalR." I mean, so do I. So does everybody else, because then it would be perfect. But
computer science only lets us get away with so many things.
That's very, very true. There's this whole thing called space-time. You can't bend it.
And someone's saying like a Cosmo DB ledger. Yeah, like Cosmos DB is one of these amazing technologies, from the very little I know about it, that kind of delivers on all these things we were told we can't have in combination. Yep. No, you can't have it's fast, it's accurate, and it's durable, and it's multi-geo replicated, blah, 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 and transactional, right? Oh, yes, you can if you have Cosmos DB. But it's still not as fast as a real-time connection, right? Because you're literally doing, I'm going to send it to you, and it gets broadcast to everyone else. And so, you could totally imagine your system, whatever it is, gaming, whiteboarding, chat, whatever it is, where you use Cosmos distributed database, basically, as the durable ledger, effectively, of whatever things that you choose to be durable that were otherwise sent over the SignalR connection.
And Chris Anderson actually does something like, I saw a demo that he did a build and then an IglooConf, I believe, where he actually does a SignalR thing on top of Cosmos DB, and he's actually drawing like a real-time drawing app on either side. It's pretty cool idea.
Cool.
But on the streaming thing, one thing I wanted to show you here is when we started to talk about streaming, when I went to the team, streaming was definitely one of those things that we could have a lot of interesting discussions on. And it felt to me like the code would be amazingly difficult.
Right.
Like, I'm like, oh my God, it's like socket programming. Like, what does this look like?
Yeah.
You know? But what's nice is it's almost as nice as is the normal SignalR APIs, like the invoke and on kind of ideas. I have to keep turning here. I'm sorry. So what I've done is I've pulled up VS for Mac here that I've got running. And what you'll see is that I've got this this web app right here, my real-time timer. So Hanselman hit me up the other day and he said he had seen a demo, I think it was an Elixir demo, of a real-time clock that went down to, I think, thousandth of a millisecond.
No, I think what it was doing, if I recall, the frequency of the update in Elixir, like it's a single millisecond.
Right.
I think, even though browser JavaScript timers are usually locked at 16 milliseconds because of battery stuff.
So that's why
So they were literally, the server-side code, I think, was attempting to do a broadcast on a 1 millisecond clock cycle.
Okay.
Because that's what the default cycle is.
Got it. Okay.
And then then other stuff happens between there and the end. But yeah, legitimately within the scope of Elixir, I believe it was one per millisecond, so 1,000 times a second.
It was super fast,
and it looked great when you looked at the browser.
So he sends me this, and I said, well, I could do something similar to that. And I sat with one of the devs on the team, Mikhail, and we worked up a quick little sample, and it was not fast. It was really depressing. Like it wasn't fast.
Okay.
And we were kind of expecting that tick 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 tick, really really fast ticking to happen. It just wasn't.
Okay.
And Mikhail said, "You're not doing it right. You should use streaming for this." And I said, "That's perfect. I haven't used streaming yet. I could totally party on this."
Okay.
So we ended up looking at the code together, and this is it. So effectively, you would just have, it's just like a hub method. You would basically say, I have I'm going to hand you back a channel reader of a particular type. In this case, it's a string. And my devs tease me. They say it's a PM. You're a PM, so you can only send a string. Like, you're not smart enough to send anything else. So I can only send this.
Correct.
Yeah, he's and then in this guy, we're actually writing out the actual time date stamp to the stream. Okay. So what I could do in this case, now I'm going to open this up using the command line, just because you'll see in a second. So I want to go here and just go to Tools and then open this up in Terminal.
Just before you run away,
sure.
Channel is a fairly new API, so a lot of folks in the community probably haven't seen it before or haven't used it.
The docs are a little thin.
And the docs are a little thin. Channel is basically a single pub multi-sub, I think. I think it's single publisher, multiple subscriber, or is it single pub, single sub? I can't remember.
Oh, no.
Someone will tell me. That lets you send any T through the channel, and you can back the channel with whatever you like. But by default, it's all in proc, right? It's just there's a clever queue behind the scenes,
right?
And it's very fast and as lock free as it can be, and all that type of stuff.
How fast is it? That fast?
Wow! And
So
but now it's a channel, and then the results of that are being broadcast out over SignalR.
Right.
Okay.
So that's actually coming out over SignalR in real time.
Yeah.
And this is using the JavaScript client, obviously. We're sitting here looking at the JavaScript
Is this JSON
client.
or protobuf?
I think this is message pack. I think it's message pack.
So if you were to open up the WebSocket visualizer in the network tools, and we were to try and attempt to count the number of frames per second that were coming from the server to this client.
Not here, you mean?
What?
Not here, you mean?
Why not?
I don't think is it going to work?
Why not? Go to the network tab, filter it to WebSockets, and then hit F5.
Convert to WebSocket?
Just filter that list to only show WebSocket requests.
Where do I do that?
Up the top, there should be see if it says all XHR JSC other, the last one. Up, yep, other. WebSocket, sorry. No, down, left, down.
I don't see it. I don't see it.
It's right there. That one.
Oh, that one.
Yep.
Okay.
So then if you've got it there. Is it already there? Then you can open it, and then there should be a tab within the scope of that connection once you select it. So that request, that you should see the payload, the messages, or whatever it's called.
Messages.
Yep. And then in real time, messages. Yep. You should see them all.
Whoa.
Right. So can anyone eyeball that and tell us how many we're seeing in a second?
What do you guys think?
Yeah. Maybe you should update this to count locally and show frames per second.
That's a good idea. We could definitely do that.
That'd be cool.
That would be cool.
And he's saying it is JSON. You're not using message pack.
Oh, it's JSON?
So you could probably make it a little faster.
Probably faster. Okay. Yeah. And then to show you what we could do on the client side, let me open this guy. Now, this is actually that's the JavaScript client that you saw over here. This one I will go ahead and do as well. Open this up in Terminal. And
We had a question while you're doing that. We had a question if these bits are public.
these bits are public.
Cool.
These bits are indeed public. This is me streaming on the .NET console client right here. Actually,
That's cool.
so you've got the client running here. And then the question that I'm sure James wants me to answer is, does this work in Xamarin? And the question answered with, of course it works in Xamarin. So this guy, I could actually go up here and F5 my Xamarin app. And it's a really simple Xamarin app, nothing big going on. But if I open this guy up, you'll see there's my emulator.
How low have you gone? Because I noticed you're doing 10 milliseconds. This is 100 hertz right now. Could you do? Because you're doing a task.delay 10.
I am, yeah.
Yeah.
How low should I go?
I don't know. Make it 1.
I got
Live dangerously. And show your CPU while you do it. Oh, you're on a Mac. I wouldn't even know how to look at that.
Oh, neither.
I could just listen for the fans, I guess.
Yeah.
I can't because I got headphones.
Uh,
It doesn't. That wasn't a diss on a Mac. Like that. My fans
get
go
a
on when
1?
I open email. You did 1. Go for it.
Go for it.
Why not? You're
Let
just
me do
basically
this.
asking the framework to schedule 1,000 different things a second.
That's good. Terminal tools. Sorry.
I'm sure the task infrastructure is perfect.
what are you writing? Teams?
That's funny.
It's funny. This is taking me back.
Is this
like,
OneDrive?
when we first wrote SignalR, we went down this whole rabbit hole of what was the frequency.
That's faster.
Look at that. What was the frequency of the timers in .NET? And we ended up. I remember writing these a timer loop in .NET because if you use a standard. The standard things that you would do off the top of your head, they're not super accurate because of the way CPU slicing works. To get a super highly accurate like game loop, like you want to run at 60 frames per second, like that's what you want, and you don't want to ever drop below that. You need to write custom game loop, and like I know Mono Game had a pretty well revered game loop. It's weird though when you write those because you write them and then like your CPU just sits at 100% because those game loops they're basically designed to sit there and very accurately do a very high frequency timer, and then detect when enough time, like 60 milliseconds has elapsed from the last time, in order to know they have to now do work to get 60 frames a second. But you can't do that by asking the CPU to call you back in 60 milliseconds because it's not a real-time OS, and the way the clocks work and the CPU cyclings, it'll call you back in milliseconds, right? So saying to it, if you were to actually leave that at 10 and then you write the code to measure how long it's actually taking, I bet you $5 is not actually 10 milliseconds.
Interesting. And
so, but you can write loops that will be more accurate. They're just a lot more expensive to write usually.
That's more of a halter.
It's kind of cool though.
That's
but yeah, anyway,
thing.
Yeah. So I remember writing one of those loops back in the early days, and it was all learning for us. We'd never had to be exposed. Like, just stopped.
Yeah, I just hit Control-C on the website.
But it did look a lot faster.
Yeah, it was faster. I actually remember one of the first conversations we ever had about extremely difficult programming. I was pinging David and Damien. I was like asking all these really wonky questions. It was right before build.
Yeah,
we had a big demo at build, and finally Damien was like, "What are you trying to do?" I was like, "I'm trying to write a backplane." And he says, "What are you sitting on top of?" And I was like, "It doesn't matter." And he goes, "No, stop." He says, "Stop! You're gonna kill yourself." It was such pain. That was an awful summer day.
Writing a backplane isn't much fun.
Yeah, it was not fun.
Yeah.
The other thing I would show you guys real quickly is I love this. This is cool. So around that same time frame, we were talking about backplanes. It was like the topic du jour, it seemed, because we had folks who were deploying to app service, or at the time was web apps. And they wanted to, slide the slider and still get, scale out. So we had to come up with a story for them, and it wasn't entirely, a fun time because we had 3 options and all kinds of difficulty with all of the above options, and we wanted to have something like an Azure service. Wouldn't it have been great if we'd had like an Azure service that handled real time? Well, we do now, and our good friend Anthony Chu has written a really great blog post on it, which I just pulled up. He has a fantastic demo that I'm going to show you here real quickly. And what he's doing is he's actually using serverless SignalR. So this was something that I love this conversation. People, they hear the SignalR service in Azure. I was just talking to our good friend Andrew Hall yesterday, and he goes, "Well, my understanding of SignalR is that it's a persistent thing, and with functions being serverless, like how does this work? And I said, well, effectively it just has a REST API, and the REST API calls in to the service, and the service does the work. The Azure Functions bindings were actually originally written by our good friend Anthony Chu. He wrote I guess he wrote the .NET ones first, or maybe the Node ones. But effectively what would happen here is you would actually call an Azure function, and when you hit that function, the function will turn around and send either the entire payload or some subset of the payload over to Azure SignalR service. And then any of your connected clients that happen to be connected to that SignalR service backend would automatically get those messages.
So I need to unpack this a little bit.
That's fine.
So the Azure SignalR service does a couple of things. One is it acts as the endpoint for all the SignalR clients connecting to your application. So in a traditional Asp Net Core SignalR application, you host the SignalR server library in your app, you create hubs, and then when you start the app, there's an endpoint there that's /hubs/whatever you want to call it, and then your SignalR clients will connect to that and create a WebSocket connection or a fallback, right? And so they're all connected to you. When you then split that out to scale out with the SignalR service, you still have your web app in that world, and your hubs are there, and the code for the hubs stays in your web app. But the SignalR service is the one that gets all the connections, and then it basically proxies between your web app and the SignalR connection. So the SignalR connections are stateful and they're connected to the service.
Right.
But then the service does the job of going, oh, I also have a stateful, permanent connection, or durable, not durable, persistent connection to the instances of your web application.
Is it durable?
I know, that's why I said not durable. And so that you can, it looks like you don't have to change any code, basically. It just has a hub, and all the stuff still works. But in this model, you then remove the app. The Asp Net Core server app is gone.
Right.
So you still have SignalR services endpoints and like a URL, and your clients connect to that.
Correct.
And so, but they can't do anything.
Right.
Because if the client code says send a message,
no
one's listening.
They're listening.
Then no one, well, hang on, until I add something else.
Right.
So I took away my web app, so now there's no hub.
Well, those clients are like your SignalR clients, insert language here.
Yeah.
They're all connected to the Azure SignalR service.
Right.
With a real SignalR connection.
I get that part.
But that SignalR connection is not connected to a hub running in an ASP.NET application.
So I've gone from like the mental model, I think, that we take people from. You have an Asp Net Core SignalR app, you split it apart, and you let the connections in. Then I get rid of the app.
Right.
So if I didn't do anything else at that point, I'd have a pretty useless experience because my connections would be connected to the service. They try to send a message, and no one's listening.
Right.
Then you add an Azure function, which can via basically a webhook.
Effectively.
It can, so this is the other way around. What happens in this scenario is rather than it accepting messages from clients, it's broadcasting messages to clients as a result of some other event taking place somewhere, like event grid or whatever it might be. Okay.
And the way that works is, show of hands, anybody in the audience. For those of you who've ever actually written a SignalR hub and you've had to do something with a REST API that like works with your hub, so you would send a message, you would do an HTTP post or a GET to your server using your web API, and then on the server side you would turn around and bounce a message out to your SignalR hub. So people have done this kind of thing in the past. Effectively, that's exactly what goes on in the SignalR service. They actually have a REST API, and when you send a message to that REST API, and it's actually documented in docs, you send a message to that API. You say, I want you to send a message, send chat message, and I want you to send this as a payload. And what it'll do is it'll send a message into the cloud, into the Azure SignalR service. Inside the Azure SignalR service, there's probably a hub. I don't know the implementation details. That's a David question. But when it goes into the SignalR service, all the connected clients are connected to the SignalR service. It sends a REST API call in, and then the service turns around and sends a broadcast message back out to all of those individual clients. So there's no hub. I mean, there's no hub that you know about. No. Theoretically.
The hub is a programming construct. Under the covers, it's all based on signals, effectively, which is just like, oh, the signal has a name. Your hub has a type name, so we derive a signal from that name, et cetera, et cetera. So this model, this serverless SignalR model, currently, as I understand it, and tell me if I'm wrong, doesn't support processing messages that clients send. So there isn't like a webhook that the service will send to your Azure function and say, oh, a client sent you a message with this filter.
Like it's let me summarize what you're trying to say for people that are out there in the audience and care about this kind of thing. If you don't have a hub class running on a server somewhere that you're connected to, you can't send a message in. You can only get messages
only egress,
out. It's only broadcast.
Ingress.
Correct.
So if you want to accept messages from clients, like the client streaming you were doing before, you have to still be running an Asp Net Core app on the server somewhere.
Correct.
Okay.
Correct.
But you could imagine in the future, maybe we would support certain scenarios or application models that are serverless.
And that's being discussed. We've talked about a couple different ways to do it, such as event creator, event hubs, or what thing in Azure do we want to send a message to? You know what I mean? Because like you got to remember, it's serverless. There's no HTTP on a server.
That's right.
There back there. There's no hub back there.
Right.
So, and if there is, you're not managing it, so to speak.
Okay.
But you can do a lot of crazy stuff with this. Like one of the cool things that I've seen Anthony do with this is like you were a consultant before you came to Microsoft too.
Yeah.
You probably did a lot of this thing called integration. You know what I mean?
Yes.
So you can do a lot of integration with SignalR and the different services in Azure. What I'll show you is a quick little demo if I can get it running. I did try it out last night. So let me go into ls cd source, and then I want to go into the JavaScript function. Now Anthony has literally got a JavaScript function running right here. I'm just going to run this in my run it right here on my computer. I'm not going to run it in the cloud. So I'll just do func start, and then I'll actually run this JavaScript function right here in the functions tools. And you'll see that I've got my functions lighting up right here, and I'll just do a new guy here. I'll cd into source and then go into my view app because he's doing this in view. And then I would say npm run serve. This will open up my view app. Theoretically. There we go. Okay, and now I can open this up in 8080. And what I'm going to do here is I'm going to bring this out into another browser. So I'm going to open it up again. Sorry. This guy I will put this guy here. And then this one I'm going to put here. And I've actually got cognitive services key already set up. So I've set this up here. And what I would do in this guy is copy this over and go to this. And this time I want to join a captioning session.
What?
And now I'm going to. Now this
What is this I'm watching?
Chat.
That is great. Can it translate? Question.
What?
Harder question. Can it translate from Australian to English?
Nothing.
That's the
can
question I wanted to
translate
ask. You ruined it for me.
Australian. Wait, who wrote this?
Anthony.
So hang on. This is using the browser's audio API, microphone API, to capture what's going on, and on the client side it turns it into text, or is that doing it through Azure Cognitive Services?
The former.
The former. So there's a client-side API that says take audio and turn it into text.
There's a Cognitive Services JavaScript API, SDK.
Wait, but does it process it locally, or does it send it to the cloud?
It sends it.
Okay,
I'm sorry.
So
Yeah,
like
you're right.
lines and boxes.
Yeah.
So there's code running in the browser that attaches to the browser's microphone,
Correct.
gets the raw audio stream, sends it to Azure Cognitive Services, which then gets you back text in the browser, displays it, and then takes that text and sends it back to Azure SignalR service, which is where potentially in a different, and then it's translated on the client or in the server.
It's translated on the server and then sent back out over the client. It's crazy.
Is the server a serverless server or an actual Asp Net Core?
Serverless server. There's no server.
Oh my gosh. Okay.
This is a view app. This is totally done in JavaScript.
What? Okay.
And this is
It's funny we don't have Hanselman here right now, because Hanselman had like a whole business where he built an app like this.
Right.
What was it called? Ghost, Whisper, Cloud,
And now we got Japanese.
Echo, Cloud Echo? Something Echo?
Yeah, Cloud Echo.
Wasn't it using Siri or something?
think
Yeah, it
was,
would
yeah.
use Siri on the iPhone,
Yeah.
and then it would dictate into your Windows apps.
Yeah.
Right.
Yeah.
It's cool. So
What
if you guys
the-
like it, I would definitely give our friend Anthony Chu a good
What
hug
the
on
what,
Twitter.
dude?
Isn't that
I want to
cool?
swear so badly right now, but I'm holding it all together.
This is difficult for him.
So
You can back
James,
away from the
if you're
mic.
listening, I need a swear button on the stream deck for when Brady comes in and blows my mind.
Okay.
What on earth?
Isn't that cool?
I literally still don't understand the architecture. I'm still
that
getting my
cool?
head around.
You need a diagram.
I literally need a diagram, because I got to the point where you had the text after you'd sent it to Cognitive Services.
Oh, you can see it all happening right
And then
here.
you
Here's
sent
everything
it-
getting sent inside the Azure function.
I'm trying to figure out where the code is that's doing the translation and how it received it.
Well,
from-
it's all.
So hang on, the browser is making like a REST call That's not
so.
over SignalR.
It's making I think the browser is making a REST call to the function.
Yes, it says, here's my text.
Here's my audio. No.
Okay.
Because it has to send up the audio to do.
We'll have to look
No,
at
but it
that.
sends the audio directly to the Cognitive Services API that turns the text to speech or speech to text.
Speech to text. Right.
Speech to text.
Speech to text.
That comes back to the browser, is my guess.
I don't know.
Okay.
I don't know if it comes back to
Anthony,
the
if you're
browser.
watching, I'm sorry that we're butchering your architecture rather than just like reading the post. But holy crap, that's awesome.
Well, he knew we were going to be here today, so he wrote that post this morning.
Oh my God. Okay, I have to read that. Okay. I need to figure out where all the bits are taking place.
Do you want to see anything else cool?
Do you have something else? We have like no time. It's an hour. So
I have something else cool.
One last demo.
I have something else cool that people can actually party on with us.
You realize you've like raised the bar for I mean, this is what SignalR has done for 7 years, if I do say so myself.
That's good stuff.
But you've raised the bar for every other demo. It's like someone's going to come here and say, so I wrote this analyzer that detects when you have an error, and you think they're all going to go, that's great, dude, but where's your flashing ASCII?
So I had this conversation with our good friend Carl a while back, and he said, I believe he told me it was a member of Steely Dan reached out to him, which I'm sure Ryan will love. And he said that, I think I talked to Galloway about this because he's a musician as well. Like the holy grail for anybody who's a musician is I want to do live jamming from anywhere with anybody, anywhere else. Okay. But there's this thing called, file size. It becomes a little bit problematic. So we started to look at different ways that we could actually build a live jamming thing. And I said, well, let's just do this with MIDI data. So, MIDI data is pretty small. It's numbers between 1 and 16 and 1 and 127. We could just transmit that data as a SignalR payload and handle it. So I've actually got code running on my Mac here, written in .NET Core that actually uses a open source MIDI library, MIDI musical instrument digital interface. And the idea behind this is I've got this sampler right here on the desk. I'll hold this up in the camera so people can see it, and I can hit sounds on it.
Oh,
is it too loud?
No, it's great.
Is that good? So I've got a couple different samples. So different stuff here, a little unpredictable.
But you literally can make more music with one of your left-hand fingers than I could do.
It's like so what I can do here is I've actually got this tiny little client running here, and all it does is it sets up a MIDI connection to this device, and that sets up a SignalR connection, and it starts listening for messages coming out of SignalR. So what I'm going to do here is actually debug this application on my little computer here. I've got two set up here. I'm not going to run the local web. I'm just going to run the console client and pray it works. So it's been working pretty well up until now. So now this guy's so it's running, and hopefully we've got the Mio. And what I want to do is I want to pull up this website, and you can see here sampler demo.azurewebsites.net. Samplar. So if you're out there watching this, feel free to hit some buttons and see if we can get some music out of you.
So hands off. Who's going to be the first person?
Come on.
More than a clap.
Sampler. What was the Azure website?
John was like, what was it? Oh, I like that.
That's the money.
Oh my goodness.
Sampler demo.
Okay, get loud.
This is fantastic. Okay, now it's just a cacophony.
No. We were upsetting the devs earlier. Elon comes out. Could you shut that off? Okay. And here's how we kill this thing.
Who says team rooms are a bad idea?
There.
You need more samples.
Oh my goodness. Oh my goodness.
So yeah, that's a little fun. If anybody out there is interested
my brain is overstimulated.
Doing any online MIDI, I had cowbell. So.
Oh my Lord.
So we could definitely have more fun with this. So.
That would be a good demo if they were just all the buttons said cowbell.
If there was a mode, at least.
That'd be good.
Where like everything just turned into different cowbells.
That'd be good.
Yeah.
Wow. Okay.
Cool. That was fun.
Brady, you've literally left me speechless, which not many people do.
This is good. It's fun times.
Wow.
Awesome.
Okay.
It's just the part where he gets out the HoloLens.
I haven't done that
What
yet.
would be amazing? The problem is, like, we wouldn't actually be able to. We don't have one of those fancy cameras that they show on the Hollywood, where we can actually show you what that person is seeing. Wow, that was incredible.
That's fun. That's good stuff.
Okay.
It's just nuts.
Okay, I literally have nothing to add. Like, that was incredible. Thank you, Brady.
You're welcome.
Let's not make it another 3 years or whatever it was before. But you've never been on the show before, so
Never
like,
been on the show.
I challenge you to top
years
what
from
you just
today.
showed us on the next show.
can
I'm not
do that.
saying it has to be soon. It could
fine.
be 6 months
That's
from
cool.
now.
That's good.
But I would love, maybe you can do a thing where people drive a robot around the table collectively over using a website or something.
Dan Fernandez already did that.
Okay, but
And they drove the car off the table. It was pretty
Did it
fun.
have
then you
lasers?
need to do better. It needs to have a sensor on it and
cool.
has to have like AI and it learns when it falls off.
We
That,
could
like
do
using
this.
an ML.NET local. I don't know. I'm just the product guy.
We could do this. Here we go. Here
Okay.
we go.
Maybe multiple robots, and each person that connects gets a robot.
Battle bots
We could do this.
Wow.
on the table
We can
in
do
front
this.
of us live on the demo.
Well, you saw the 3D demo that I did. I thought about doing that as a each client. So there's a 3D demo that I've got where you're looking at basically a plane in space. I thought about each client that jumps in is a different camera. So we're all looking at, we all have a
Yes.
different vantage point.
Yes.
That could be cool.
Yes.
Yeah.
I think we need to use the cognitive. So, like, maybe you don't get to directly control the robot, but you get to. There's a camera that's feeding the robot's positions into cognitive services
You have to
using
talk
the
nicely
visual
to
recognition,
it.
and then you have
Turn
to either
left.
play it nice music through this thing,
That's awesome.
and then we can again use cognitive services to
cool.
decipher it. Yeah, is it a
Be fun.
positive message?
That'd be good.
Yeah,
Be fun.
I don't know. This is crazy.
So people are begging for links to repos.
All
I
this
mean,
code, yeah.
You'll have code.
Thank you.
You will definitely have code. This one is actually already out. You get a Brady Gaster sampler.
I mean, a lot of them are just in your GitHub, right?
Yeah, here's this one. So Brady Gaster sampler. That's where the one that you just, the last one.
Which requires hardware, obviously.
Which requires hardware.
Yeah.
That one, I would encourage only synth musicians to go
Now,
out there and look
all
at
the
that one.
people who were pushing buttons couldn't hear anything, right? It's only
Correct.
us who
They,
can hear
they,
it.
they could hear if they were watching the show.
Yes.
Yeah.
So that was like,
Yeah.
that's probably the first time that you've had that be on a live stream where people could go and do it and then hear back real time, or have you done that before?
I did it at Ignite in October.
But that was in a talk.
That was in a talk
Wasn't
that was
live streamed.
being live streamed.
Oh, okay.
So that got a little confusing, but in that one we did it a little bit differently. We had it set up so that you had to be one of the first 10 people to hit the site, and you only got one instrument. So you might get a bass drum, or
interesting.
you might get the cowbell.
Interesting.
So yeah,
Okay.
that sounded awful. I thought maybe I could like orchestrate people. It didn't
Did
work
it work
out.
out
Didn't
so
work
well?
out.
Okay.
Yeah, well, next time you can conduct. Like when I
Okay.
wave my hand, you hit the kick, and when I wave my,
Well, if you look carefully at the repo history for this repo, you'll see that it used to be called Conductor.
nice.
Nice. All right.
So
It's wonderful.
Thank you so much
Thanks a
again,
lot.
Brady.
that was fun.
John, do you have anything to sign us off with, or
I can't beat that.
no? That's a fair point. That's not, all right. Do we have a guest for next week lined up, or is it just the ye olde?
I forget, honestly. I think I was bugging, Barry, and he kept wimping out. I do
You
have some
definitely need
other
a
people.
profanity filter.
Yes.
Yeah. Yeah. I think I had asked somebody, but honestly, I don't remember off the top of my
Okay.
head.
We'll get that figured out and then let people know.
Pretty cool.
Yeah.
Thank you, everybody. I will figure out if I can hit the right button to end. Oh, it says end stream. I'm assuming that that's the right thing. Oh no, I'm
Yeah,
supposed to
and
hit.
it actually does magical things when you
And
hit the.
It'll
yeah.
go. It'll stay on for a minute, but without our mics and without our faces, right? And then the stream will end.
Oh, you know what? We do have somebody lined up for next week. It's Taylor Mullen talking Asp Net Core tooling.
Sweet.
Ooh, okay. That'll nice.
That's a good one.
And so
Yeah.
I can. It's a sneak peek. Taylor works on Razor Blazor tooling. So he'll be showing you all the goodness for Blazor tooling.
That thing ending with Azure.
Azure. All right.
Well, I talked about we should put SignalR and Blazor together and just call it SizzLR.
I think we could come up with a better name, but that's not a bad effort. Let's not go with the first one though. Let's make sure we roll that around a little bit.
That's good.
Okay. All right. Thanks everyone.
Thanks a lot.
All right.